This video will discuss how to create a C control chart in Excel. The C typically stands for conformity, and what we're doing is measuring either the number of conformities or nonconformities in a sample of items. In this example, we have 20 samples of 100 calls to an IRS telephone center. What we've measured are the number of nonconformities on all of those 100 calls. In other words, this may be instances where customers weren't treated politely, customers were given wrong information, or anything else that was wrong. The thing that we're measuring here is not the percentage of calls on which these events happen, but the number of times on all calls that these happen. Although we don't see it in this data, what we need to realize is there's really no limit to the number of nonconformities that could occur on the 100 calls. We could have more than 100 nonconformities. We could have 200, 1,000. Fortunately for the IRS, we don't see that in this particular data set. To create the C control chart, we first need to average the number of nonconformities. This is 11.25 for this data. Then we need to calculate the standard deviation of the distribution for these nonconformities. In this case, the standard deviation is fairly simple. It's simply the square root of the average. For C charts, we always assume that we set the control limits a certain number of standard deviations above or below the center line. This would be at the discretion of the manager. Values for this value Z could be 2 or 3, but it depends on how wide we want to set the control limits, or how closely we want to monitor the process. We'll use Z equals 3 in this example. We'll establish the center line for the control chart. The center line for the control chart is just the average of the nonconformities. We enter this with an absolute reference, and then we can copy this to each row. The lower control limit for the control chart is the center minus the Z value with an absolute reference times the standard deviation. The standard deviation also has an absolute reference. Once this is entered, we can copy this value down the worksheet. Although we don't see it in this example, it's possible that the result of this control limit formula could be negative. If that was the case, we would want to set the value as 0. Control limits for C charts can't be below 0. One thing we can do to make sure this always happens is use the max function in Excel. We can enter the maximum of 0 or the lower control limit formula. If the result of the formula is negative, this function will set the value to 0. If the result is positive, it will simply maintain the value of the lower control limit formula. In this case, because the value calculated to positive, we simply maintain that value. The upper control limit is the center, plus the value for Z established by the manager with an absolute reference, times the standard deviation with an absolute reference. With these 4 columns calculated, we're now ready to create the control chart. We highlight the 4 columns, including their labels. Go to Insert. Select the Insert Line Chart option, and select the second option down. To view the chart more easily, we can place it in a different sheet. First, we'll name the chart. Right-click in the white space at the top of the chart. Select Move Chart. Select New Sheet, and enter a name for the new sheet. What we see here are a lower control limit that is represented by the gray line, and an upper control limit that's represented by the yellow line. We see 3 points outside the upper control limit. These are clearly cases where we had a number of nonconformities on the IRS calls, and we would want to investigate what the causes were at that point. While the cause could have been the people that were on the phone, it's quite possible that the cause could have been the system, and the principles of total quality management would really encourage us to first investigate the system. The 1 point below the lower control limits is actually a positive occurrence in the sense that there were no nonconformities. As long as our measurement process was working okay, we might want to investigate the cause of this point to see if there's anything that we could do to improve the process.